Hi there! In this video we are going to discuss how to prioritize machine learning monitoring metrics. Previously we discussed the logging, and now let's discuss what exactly to log to be able to build monitoring dashboard. It heavily depends on what is your primary monitoring goal. In case your goal is alerting, you can log quite a few metrics to be able to detect an issue. Right? In this case, all your metrics will be a source for alerting. In case you focus not only on alerting but also on debugging and analysis, it makes sense to log some additional context so that you can cover more potential problems. In this case, you might log not only main metrics but also some additional metrics and even some descriptive statistics. It will help you to capture some data to cover unknown unknowns potentially. Now let's discuss a hierarchy of the metrics which you might want to have. Basically, the hierarchy here starts from the symptoms. Those are metrics which help you to build an alert and figure out whether there are any issues with your model. Then you have some summary metrics which can provide you with additional context. Input, output, and performance profiling to give you more details. Finally, debugging and analytics data, and all this hierarchy based on the raw data, prediction level data, which you can customly query. Let's take a look at the example. As a symptom, you can measure any quality metric or business KPI. For example, let's have a classification problem statement, and in this case, you can use 1 day accuracy, 1 hour accuracy, 10-second accuracy, everything that can be served for alert, right? As a summary metrics, you can give additional quality metrics like prediction volume, true positive, false positive, or even share of missing data, so that you have some additional summary signals related to the quality of data or model performance. Going deeper, you can add some input, output, and performance profiling, like, for example, per column descriptive statistics, distributions, mean, max statistics, whatever makes sense for your problem statement and your data. Going deeper, for debugging, you might add some additional metrics like correlation, explainability, and anything else. And finally, on the bottom of this hierarchy, you can have prediction level data, which you can query with any custom queries, right, in order to calculate any custom metrics, build up any custom visualization, or find some particular rows, particular objects, which are objects of interest. Let's take a look at the monitoring depths. If you take a look at this hierarchy from top and the bottom, I can say that at the top you have very minimalistic monitoring. At the bottom you have like detailed, in-depth observability. Both works just fine, but make sure that it helps you to reach your monitoring goals. You can totally have minimalistic monitoring if you have just a few models in production, or you have very small data set. Maybe the use case is less critical, or maybe you build your monitoring for technical users only, and these technical users have easy access to your raw data so that they can query those data and perform debugging themselves. You need in-depth monitoring if you have a lot of models and you want to standardize debugging and MLOps, right? Maybe you have large data sets and very critical use case. Or maybe you build up your monitoring system for many different actors, including business stakeholders, which prefer to perform some analysis using BI tools without the need to query raw data. Well, the good question is, what is the middle ground? What is the good starting point? And I would say it's really very use case specific. I could suggest something in the middle, like, for example, you can use as a logging data symptoms, summary metrics, and some performance profiling. For instance, you can pick up a few key indicators to use as a source for your alerting, then add a little bit data related to per column data summary and performance summary, just to simplify immediate troubleshooting. And you can live with this setup for quite short period of time in order to get some feedback and think through the rest of the metrics case by case. So now let's move to the metric prioritization. Basically, in short, we always start from the software health. I will repeat it always because that's the basis. And then we can add additional layers like model calls, outputs, data quality, and model input. I personally believe that software health, model goals, and outputs is the must, and then you can add up data quality and model inputs. So let's start from the service health. Basically, service health monitoring helps us to answer the question, does the service work, right? And that's very important. To build up your service health monitoring, you can use the standard approach, which you use for any other services, not necessarily machine learning based, so it's a lot of technical metrics. But just in case you have pretty complex model, for instance, your machine learning based service can have several models or even some rule-based system, right, which you use as a fallback in case something is wrong with the input data or with your machine learning model. In this case, it makes sense to measure which particular model answered to you so that you can have some statistics on how often do you use different levels of your fallbacks and figure out what actually works in your service. Moving further, the next question is, how does the service perform? Did anything break? And for having this observability, we can use model performance metrics. It also depends on your use case, and, well, it's always good to pick the best available signal so that you can react very fast and figure out what's going on with your service so that you do not miss any issues. So basically, it always starts from the very direct signals like business KPIs, for instance, resolve support issues, etc. Or you can use some direct model quality signals like quality metrics, precision, recall, accuracy score, root mean squared error, or whatever makes sense to your use case. Quite often, we just cannot use these direct signals, for example, because of delayed ground truth, and in this case, we can move to the proxy data, like some heuristics, for example, percentage of clicks on recommendation blogs, downloads, etc., or maybe some output range compliance, like non-negative sales, etc., or output distribution drift, so anything which is related and closely connected with your direct signals, but unfortunately is not direct signals. But you have enough data to calculate those proxy metrics. It also works quite well. When we build the monitoring system, the idea is to create some alerts on top of those chosen KPIs, so make sure that your KPIs is something to what you want to react if it breaks some thresholds. If you want to log more data for debugging purpose, you can, together with those metrics, log some additional statistics. For example, log distribution of output, right? In this case, you will be able to see if, for example, you detected the prediction drift, what exactly drifted, how the distribution has changed. This is why it's quite convenient to log some additional data so that you can see what has changed straight away without querying the raw data. Also, you can add some additional data related to model error. For example, if model quality dropped, how, where exactly. Maybe model quality dropped on the particular type of objects or maybe on the particular region of some important feature values, right? So it makes sense to split your error into the buckets, for example, by target value or maybe do bucketing by other features, of course important ones, and see the error distribution. It can give you some additional information and some insights on how to fix the issues. Going deeper, the next block of metrics is data quality and data integrity. If we detected some issues with model's performance, we are very interested in what has happened, where did the model break, can we trust the data, and data quality and integrity helps us exactly with that. Basically, there are two methods you can use to analyze data quality and data integrity. The first is track data health metrics like share of missing values, maybe share of features with type mismatch, share of duplicates, etc., etc. Or instead of direct metrics, you can build a test suites on top of those metrics, and periodically you can run some scans with a large number of checks to see how many data quality tests or checks were broken. In this case, you track not the metrics themselves, but rather track the number of failed tests. You can differentiate between fail and warning tests in order to decrease the amount of false alerts. Basically, if you track data health metrics, you would have something like share of missing values plot, which you can see from the left side, right? And that's the value of the metric in time. In case you track tests, you will see something like the bar plot from the right side, so that you can see the amount of failed tests, warnings, skip test success, etc., so that you can build up a picture of what's going on. Of course, if you see that there are quite a lot of fails, you can see what exact tests were failed and analyze the metrics inside of those tests. It makes quite a lot of sense. If you want to log some additional data for debugging purpose, you can log some dataset or column statistics. For example, statistics like count, mean, standard deviation, mean, different quantiles, etc. Maybe even distribution data, so that you can visually analyze the columns and your dataset in general. So that you can see what is the source of data shift, do you have any issues with most common categories or maybe missing values or whatever it is. Finally, we have the data and concept drift. It helps us to figure out is the model still relevant, right? And in this case, what we can do is build data drift monitoring. To simplify the alerting, we can look only at key drivers, prediction drift, or dataset drift in general. So basically, we can build up this data drift monitoring for any kind of data. Previously, we discussed data drift for embeddings, text, and of course, you can build it up for tabular data. And you can track the share of drifted features for the whole dataset so that you can get alerted only if a lot of features has drifted. As for debugging, you can log some distributions so that in case of drift, you can see how the distributions look on different periods of time and compare it. Well, when it comes to comprehensive monitoring, you can always adapt some additional layers depending on your problem statements and the scenario of model usage. For example, together with service health, model performance, data quality and data integrity, and data and concept drift, you can add performance by segments, especially if you have quite complex audience or quite complex object structure and you know that there are different groups of objects you want to monitor separately. Maybe you are interested in model bias and fairness. For example, if your problem statement is related to very sensitive domain area, like healthcare, right? You might monitor for outliers if each individual error costs quite a lot. Or maybe you share with your users some information on how you generated this particular output, why you recommended this content to a user. In this case, you might want to share some information about explanations, and if you do that, it makes sense to monitor explainability as well. Well, to sum up, we always start building our monitoring from service health. Service health is a must for production models. Then we need to make sure that we store prediction logs. It can be part of our event logs or just prediction if you work with the batch model, right? We might limit our alerting to key metrics and symptoms because it's already solved majority of issues. And we can define depth of monitoring based on our needs. When we are in doubt, we can go for the middle ground. For example, select the limited amount of metric types like model quality, data quality, and data drift, and build your alerting system only on top of few metrics. Like, for example, select the best quality metric, the best performance signal for your model quality, and set up alerts only, for example, for mean absolute error. Same we can do with data quality and, for example, react only on share of failed test if the share of failed data quality test is like higher than certain threshold, for example 50% or more, right? And for data drift, you can also react only on share of drifted features but ignore the drift of each individual feature. For debugging purpose, we can use and store more metrics like error distribution for model quality, dataset and per column descriptive statistics for data quality, and per column distributions for data drift, so that we can address the issues faster and get some additional context in order to figure out what's going on and troubleshooting. I hope it helped you to figure out how to prioritize the metric and build your monitoring system which is relevant to your particular model and your use case. Next, we will discuss the training system because it's closely connected to the model performance and can depend on the monitoring.